Now let's see how we're going to represent complex numbers in our machine. Now we could write the complex number z is equal to 3 plus 4i. In this instance, the real part of z is the 3 and the imaginary part is the 4i. Now how are we going to represent this in our machine? Well, we could use the idea of an array. So we could say something like we'll have our DC for defined constant, and we can call this our array, which is going to be, say, C1, which would be complex number 1, and we simply put in the values 3, 4. So we interpret this as a complex number. The first value here is the real part, and the second part of it here is the imaginary part. So the first thing we want to be able to do is get the real part from the complex number and the imaginary part from the complex number. So all we really need to do then is have this as the input to a subroutine, and in order to return the real part, we simply return the value 3. In order to return the imaginary part, we return the value of 4. So let's go and we'll see that within our assembly language code. So let us first of all look at returning the real part of a complex number. On the right hand side we have the calling function, on the left hand side we have the subroutine. So in the calling function, I've called the complex number simply complex, and it's 2, 3. So this represents the complex number 2 plus 3i. Then we've got an address that will save the real part of the value, which in this case will be a value of 2. And we push the complex number, we push the position for the saving address, and then we jump to the subroutine. And then we jump into the subroutine and it will return the value of 2 into this location defined by ds real underscore address, and that will be the end of the code. So let's look at the actual code itself. So it's really pretty straightforward. We save the values for our registers, we pop the return address, we pop the address for the result in R2, the address for the complex number in R1. We then load the actual value of the complex number into R0. So this will just take the very first value, which is the value of 2, and then we store it to the location that we want to, which again is in register R2. And then we return the values of our registers back to their original values, and we jump to the return address. So we jump to the end, and that's it, finished. So that's how we do the real part of our complex number. So let's look at the imaginary part next. On the right hand side we have the calling function, on the left hand side we have the subroutine. So the calling function now calls the function math underscore complex underscore im. Im is for imaginary. So again, we push the complex number, we push the imaginary number address, and then we jump to the subroutine. It goes through the subroutine and it picks out the number 3 and it returns that number 3 to the imaginary address. So that's the calling function. Let's look at the actual subroutine. So again, we store the original values of our registers, we pop the return address, and here we pop into R2 the address of the result, so that's imaginary underscore address, and we pop the address of the actual complex number. We then increment the value of R1 because we don't actually want to get the value of 2, we want the next position along. So in effect we're incrementing this address position. So once that address position has been incremented, we can then load the value that's in that address, in this instance it's the value 3, into register R0, and then we can store that number 3 into the address in R2, and the address in R2 is the imaginary underscore address. So that's us finished, and we can return the registers back to their original value, and then we jump to the return address, and that will be the end of the code. So it's really pretty straightforward, generating the real part and the imaginary part of a complex number. Let's see this actually happening within the CPU. I have added the subroutine into the ROM and the calling function into the RAM, so let's run it now. Now this should be pretty quick, and all it's going to do is return the value of 2 into a particular address. So that's it finished now. So if we stop this and we head into the RAM, and we'll see if we come down to 8500, the original value for the complex number is 2 plus 3i, and in the very next memory location it has returned the value of 2. So it has returned the real part of this. So if I was to run the code for the imaginary part, it would return the value of 3 into this location. So that's a start on complex numbers. Let's continue over the next few videos, and we will program in a few more functions which deal with complex numbers. So thank you for listening. I'll get you on the next video. Goodbye.